Hello everyone, in this video we are going to learn about star-delta transformation under DC circuit theory. Star-delta transformation. Star-delta transformation and delta-star transformation allow us to convert impedances connected together in a three-phase configuration from one type of connection to another type of connection. So here you are seeing that this is called as the star connection and this is called as the delta connection. T connected and equivalent star network. So here you can see that this type of network you will familiar with basic electronic circuit. So now we are going to analyze what is star network. So here the most important thing you have to consider is we are calling this star network as the T network. So normally this T network is the star network. So now you can see that here this is the center point A and this point 1, point 2, point 3. Here you can see that from point A to 2 Q resistor is connected. From point A to 2 Q resistor is connected. From point A to 1 P resistor is connected, and here also point A to 1 P resistor is connected, and from point A to 3 the resistor R is connected. So likewise here point A to 3 R resistor is connected. So this is the same network, so the equivalent network. So normally the star network is the equivalent circuit of the T network. Previously we have analyzed about star T network. So now we are going to move pi delta network. So here as the same way you can see that here this pi network can be transformed into the delta network. So here you can see that here I am going to mark the points point 1, point 2 and these are the point 3. So here you can see that here there are three resistors are connected A, B, C. Likewise here point A to 2 A resistor is connected. Point A to 2 here A resistor is connected, and point 2 to 3 C resistor is connected. Therefore likewise here point 2 to 3 C resistor is connected, and point 1 to 3 B resistor is connected. Here point 1 to 3 B resistor is connected. So here pi network. So here we can derive this pi network as the delta network. So almost these are the same or the equivalent circuit. So I hope you will clear with the basic concept of star delta connections. Now we are going to deal with the delta star transformation. So here this is the delta, here this is the star network. So we are going to compare these two networks and we are going to take some mathematical expression or mathematical relationships. So here there are 3 points we are going to consider: point 1, point 2 and point 3. Here also we are going to place 3 points: point 1, point 2 and point 3. Now here we are going to connect the same point. So here for an example, this point number 1 is going to connect with this point number 1. This point number 2 is connected with this point number 2, and this point number 3 is connected with this point number 3. So now we can get some mathematical relationship. So here in between point 1 to 2 for this delta network there is a resistor, but here in the star network P and Q are here, but these P and Q are in series. So here in between point 1 and 2 P and Q are in series. Therefore we can write as P plus Q equal to A. Here we are going to comparing. So P plus Q equal to A. But now this A in parallel with this B and C. So again we can write as equal to A in parallel with this B plus C. Therefore the equivalent resistor will be product of two resistor A into B plus C over A plus B plus C. So this is our equation 1. Likewise, in between point 2 and 3, here C resistor is connected. Here in between point 2 and 3, R and Q in series. So R plus Q. Again, we can write another relationship. Here R plus Q will be equal to C. But here this C resistor is in parallel with this A and B. So here A and B are in series. So again we can write as that is equal to C connected parallel with this A and B, but A and B are in series. Therefore the equivalent resistor will be product of two resistors. Therefore C into A plus B over C or sum of three resistors. Therefore we can directly write A plus B plus C. So this is our second relationship. Therefore I am going to consider as the equation number 2. Likewise, in between point 1 and 3, here B is connected. Here point 1 and 3, P and R is connected. Therefore we can write another relationship. B will be equal to P plus R. Here B P plus R equal to B, but here this B is connected in parallel with this A plus C. Therefore likewise again we can write as B into A plus C over sum of three resistors A plus B plus C. So this is I am going to consider as my equation number 3. So here are our three equations. So this is our equation 1, this is our equation 2, here is our equation 3. So now we are going to solve these three equations. So the initial step I am going to do is I am going to subtract this equation 3 with this equation 2. Therefore P plus R minus Q plus R. P plus R minus Q plus R. Here R and R will be cancel, so P minus Q equal to B into A plus C over A plus B plus C minus C into A plus B over A plus B plus C. So again here BA, so here A plus B plus C we can take as a common, so BA minus CA, here plus CB minus CB will be cancelled. So here we will get this relationship. Again we are going to add equation 1 with equation 2. But here adding together equation 1 and the result above of the equation 3 minus equation 2, here P minus Q, here our equation number 3 P minus Q, and so for an example, for the easy purpose, here I am considering this equation as my equation number 4. So here I am going to add this equation 4 with equation 1. So here you can see that here we will get the value 2AB over A plus B plus C. Previously we got the equation 2P equal to 2AB over A plus B plus C. So again we can solve this. Here these 2 and this 2 will be cancelled. Again we will get the relationship for the P. The P will be equal to AB over A plus B plus C. Likewise, here this is what we mention here. So P will be equal to AB over A plus B plus C. So likewise we can get for the Q, Q will be equal to AC over A plus B plus C. And if we get the relationship for the R, R will be equal to BC over A plus B plus C. So when we converting a delta network into a star network, the denominators of all the transformation formulas are the same. Here you can see that all the denominators A plus B plus C. Here also A plus B plus C. Here also A plus B plus C. So the denominators of all the transformation formulas are the same, and which is the sum of all the delta resistances. Then to convert any delta connected network to an equivalent star network, we can summarize as the above transformation equation like this. So I will do some questions. Here is an example question. Here we need to convert this delta network into the star network. So here all the resistivity value of the delta networks are given. Here A is 20 ohm, B is 30 ohm, C is 80 ohm. So here we need to convert this delta into the star network. But for the star network, I am considering the resistivity value as P, here Q, here R. So from our previous transformation equation, we could easily find out the resistivity value for the P and Q and R to convert this into the star network. So we got the equation for the P equal to AB over A plus B plus C. So now we can substitute the values for A and B and C. So here A is 20 into B is 30 over 20 plus 30 plus 80. So if we solve this, we will get the value for the P as 4.61 ohm. 4.61 ohm. Likewise, for the Q, we got the transformation equation as AC over A plus B plus C. So again, if we substitute the value for A and B and C, we will get the value for the Q as 12.31 ohm. Likewise, R equal to BC over A plus B plus C. Again, if we substitute the value for A, B and C, we will get the value for the R as 18.46 ohm. 18.46 ohm. So now we can redraw our star network by using or by applying this value. So here if we use 4.61 ohm, here Q 12.31 ohm, here R 18.46 ohm. So this is the equivalent star network to our delta network. So very easy question. Up to now we have learned about delta to star transformation, but now we are going to focus on the star to delta transformation. Here is our star network and here is our delta network. Here by substituting the value for P, Q, R, we will get the value for the A. By this equation we can get the value for the B, and by this equation we can get the value for the C. Then after we know the value A, B and C, then we can substitute the equivalent resistor by the delta network and we can simply get the equivalent resistance or equivalent circuit. So I will show you by an example question. So here this is our star network. So here for the star network we need to find the transformation of the delta network. So here the value already given, but we have to find this value. So I will show you how to find the value. Here directly we can use the equation as we learned in previously. A will be equal to PQ plus QR plus RP over R. So here we know the value P and Q and R. So we know the value of the P, we know the value of the Q, and also we know the value of the R. Now we can substitute this value for this equation. So the P is 150, Q is 180 ohm, R is 60 ohm. Then if we substitute this value, we will get the value for the A as 780 ohm. If we solve this equation, we will get the value for the A as 780 ohm. Likewise, if we want the value for the B will be PQ plus QR plus RP over Q. So if we substitute the value, we will get the value of B as 260 ohm. Likewise, for the equation C, PQ, C will be equal to PQ plus QR plus RP over P. Then for this equation we can substitute the value for PQR. Then we will get the value C. C will be equal to 312 ohm. So this is very easy question. So here the one thing you have to note down is, here we can directly use the equation. We don't need to compare and get the relationships. Here we can directly use this equation to find out the value of A, B and C.